Evening viewer, welcome to our Glory Globe TV's amazing news for viewer. Yeah, ischemic heart disease is the leading cause of death worldwide, and it often starts with a heart attack, medically known as a myocardial infarction in the short form MI. Yeah, which occurs when blood flow to part of the heart is blocked, and this lack of circulation causes heart tissues to die, triggering intense inflammation, structural changes in the heart wall, and ultimately heart failure. Despite inflammation playing a key role in this process, anti-inflammatory drugs have not been effective at preventing heart failure. As a result, they are not routinely used after a heart attack. For the same, researchers suspect this may be because the most critical inflammatory pathways and cellular targets have not yet been identified. In a study published in Nature, a team at the University of California, San Diego, led by Dr. Kevin King, Associate Professor of Bioengineering and Medicine 2, also cardiologist at the Salpizio Cardiovascular Center, uncovered a previously unknown mechanism of inflammation in the heart. Their findings could open up new possibilities for therapies aimed at stopping a heart attack from progressing to heart failure. Typically, post myocardial infarction inflammation is thought to come from immune cells like neutrophils and macrophages, which flood the damaged heart tissue and react to the debris from dying cells. But the UC San Diego team found something unexpected, a strong inflammatory response, specifically the activation of type 1 interferon, that is the short form IFN signaling. Yeah, was not located in the damaged area itself. Instead, it occurred in the border zone, the area surrounding the infarct where heart cells are still alive. The border zone has been a fascinating yet understudied area of the infarcted heart, and it is where surviving heart muscle cells attempt to stabilize and even pro life after being disconnected from their dying neighbor cells. Unfortunately, the border zone has proven a challenging region to study because it is not easily isolated from the rest of the heart. Researchers overcame this obstacle using methods they recently reported based on single cell RNA-seq and spatial transcriptomatics, where cells of the border zone are recognized based on their patterns of gene expression. To determine which cell types initiates border zone inflammation, the team created a library of conditional knockout mice, each unable to initiate IFN signaling in a different cell type, and to their surprise, heart muscle cells called cardiomyocytes emerged as the dominant initiators of border zone IFN signaling. They found that mechanically stressed cardiomyocytes at the border zone frequently suffered nuclear envelope rupture, which allowed escape of nuclear DNA and sensing by systolic DNA sensor, leading to activation of IFN signaling. This is in turn caused mechanical weakening of the heart wall and made it vulnerable to dilation, thinning, and rupture, providing a mechanistic explanation for the team's previous reported observation that mice lacking IFN responses exhibited improved survival after MI. Amazing, sir. Bow down. Behind this exclusive report, Glory Globe TV, Delhi, Bharat.